out the slope on a graph grid, and we're going to do some equation writing of lines. I do think a lot of this will be review, so hopefully that's kind of nice for you. This is not on your note sheet. This is just literally out of my Algebra 1 material, just to review how you do slope of a line. Slope, of course, represents how many units we rise compared to how many, of course, the run, the left to right. And remember, anytime you're analyzing a graph, whether it's a line, parabola, anything, you always analyze left to right. So of course this line is rising left to right, so it has what we call, of course, a positive slope. Now, two different calculations, two different ways we're going to calculate slope today, and it depends on what they give you. If they give you the two ordered pairs, we're going to do our old school y2 minus y1 over x2 minus x1. So remember, the y's represent vertical change, so that's your rise, x horizontal, the run. Now notice too, let's just talk about nitpicky details, of course, on the bottom here where it says x1 cannot equal x2. If those were the same numbers, let's say they were, I don't know, 5 and 5. Well, what's 5 minus 5? 0. Can you divide by 0? No. So that's just that little, hey, you can't divide by 0, they can't be the same. 0 under the line is undefined. Now, if I'm on the graph grid, if they give you the picture of the line, which you will see that today too, I'm literally just going to count rise over run. That's really messy. Let me rewrite that, rise over run. So just remember, of course, you're counting up and down first, then you count horizontal, left to right. I know you know how to count slope, but hey, you gotta do my due diligence. Now, slope, of course, is important because it affects how the line looks, and it tells you how steep the line will be. So positive slope is gonna rise left to right. So then, of course, a negative slope falls. Now, zero slope. So I'm like, ooh, zero slope. So I'm thinking about my fraction. My y2 minus y1 over x2 minus x1. If it's going to be 0, the top would have to be 0. The bottom can be anything. I'm just going to make up a number. So I'm thinking about, okay, 0 on the top, rise over run. So you do not have a rise. So you're not going up and down at all. So that means you're only going left to right. So that's going to be, of course, a horizontal line. So all horizontal lines have a slope of 0. Then, of course, the opposite, if we flip it, undefined, we talked about 0 under the line is undefined. So now I'm like, okay, I don't have a run. If I don't have a left to right, I don't have a run, you only have a vertical, up and down. So vertical. And you're going to see some horizontal, vertical lines we're going to draw them here in a minute. Not that those are hard to draw. So just a little summary of how slope affects the look of your line. Okay, so here we go. Sketch the lines through the points with the indicated slopes on the same set of coordinate axis. Notice they give you 4 different slopes. So we're going to have 4 different lines on here. Now, power of the smartboard, I'm going to color code them, of course. You don't have to, but just, hey, that's how I'm going to roll. First thing I'm going to do is plot my point, -4, 1. 2, 3, 4. So every line I draw is going through that black point I just put on there, okay? I'm going to do, just to color code it here, I'm going to do the 4 in red. And I'm going to, for slope, I know you know it's over 1, but I'm just going to put it in fraction form. So from my beginning dot over there, I'm going to now count the slope out. Rise 4, so up 4, run 1, right 1. So up 4, right 1. Start counting. Now, because of my lack of drawing skills, I'm going to do another point just to try to help me draw it a little nicer and straighter. And if I were to go off the graph grid, if I wanted another point, you could go down 4, and which way 1? Left. 2 negatives. Good. All right. Why not? Let's do it. All right. I'm going to try to draw a straight line through there. As good as it gets. Okay, we got 3 more slopes, 3 more lines to draw. I'm going to do -2 in green. I'm going to put it in fraction form, of course. Starting at that same original black dot that we started with. Rise -2, down, run 1. So I'm going to go down 2, right 1. 1, 2, right 1. I'm going to put a couple points on for my lack of drawing skills. Can't be good at everything. 1/2, I'm going to do that one in blue. So of course, rise 1, run 2. So from our original black dot, which is getting hidden here, I'm going to go up 1, right 2. Up 1, right 2. Pretty much lost my black dot under all of that, but it's okay. All right, and I'm going to do undefined in black. Now don't let undefined scare you. We just talked about it. Undefined slope is a vertical line. So I'm just going to draw a vertical line, well, I can't hardly see it, through this black dot, which is right in the middle of all this. Masaru. So the first few problems will be like this. They'll give you original starting point, and then you're going to practice just counting out the slopes. Nothing too crazy. I don't expect them color-coded or anything like that. You can just mark them out and draw them on the graph grid. Any questions on how I counted the slope? All right, moving on. Find the slope of the line passing through the points. So this time I am not counting rise over run. We're going to use our formula. I'm just going to jot the formula here in front of us. I know it, but that's our formula we're going to use. So we're going to subtract the y's, subtract the x's. I'm going to label the points, of course, my first x, first y, second x, second y. And really the only thing, just be conscientious of your signs when you're subtracting. So y2 minus y1, x2 minus x1. And let's just simplify. Negative 8 over 2, negative 4. Yeah. And I probably have more work than you need to show on your homework. Like I know some of you can probably just go to negative 8 over 2, do the subtracting in your head. Okay. All right, same thing here. I'm going to label x1, y1, x2, y2. So same thing, y2 minus y1, x2 minus x1. So positive 3 over 2. Does it reduce? Does it divide out? Leave it. So any questions on calculating slope when they give you 2 points? Too easy. Love it. Okay. Now, point slope form, which I also put up here, just to kind of point out your eye to it here on the front board. Anytime we're using like some formulas or anything, like you can see I'll kind of throw them up here so they're just in front of us. Like for the other classes, I got some different stuff up here too. So we're going to use what's called point slope form to write equations of some lines coming up here. You're going to use this whenever they give you a point and the slope. Who would have thought? Kind of goes together. So point slope form, I'm just going to copy down that formula over there. And the 3 numbers you're going to have to substitute into here. You're going to have to put in the slope, of course. And we just talked about how to find that, whether you're going to count it on the graph grid or do your y2 minus y1 over x2 minus x1. And then the other 2 values you're going to replace in here are these guys, the x1 and the y1. So those, of course, are the coordinates of a point. So your x coordinate, and obviously this is your y coordinate. And of course, oh, that's a sloppy r there, sloppy r. And then of course you're going to have to distribute, maybe combine some like terms, do all the little algebra stuff. Slope you know how to do, and we're going to plug in the point. So this is when they do not give you the y-intercept. That's a different equation, which you might know that one, I'm guessing. So use the point on the line, the slope of the line, find 3 additional points. There's many correct answers. Okay, first, there's many correct answers because it's a line. There's an infinite amount of points on the line. So my 3 points might be different than your 3 points, still all right, okay? So before I get into the points, I would first come up with the equation. Don't let the fact on this one seems kind of weird, the slope is 0. Same process. Point, slope. I'm going to use point slope form. So I'm going to label x1, y1, that's my slope. So I'm going to plug those 3 numbers in to our point slope form. Then I'll probably do a little distributing, see where we're at. So y minus the y coordinate of the point, I'll make that a plus in a minute. Slope, it's weird at 0, x minus x coordinate. Now on the right side, I'm really not going to distribute the 0, because what's 0 times anything? 0. And then let's just subtract the 2 over. So once you have the equation, I can get you as many points as you want for it. They want 3. So I'm just going to kind of set up my ordered pairs. Now, your equation does not have an x in it. Don't let that scare you. That's totally okay. It just means, of course, our y coordinates are all -2. It's going to be -2 no matter what. And you can pick any number you want for x. So, I don't know. I'm going to be lame. 1, 2, 3. Pick whatever you want. I did 3 different ones earlier, okay? Now, think about this. If you were to plot those points, you can kind of picture 1, -2, 2, -2, 3, -2. It's going to make a horizontal line because you have 0x in here, 0 slope, 0 slopes, horizontal lines. So that's why you've got the same numbers there. All right, let's do one where we don't have a slope of 0. Might be a little more exciting. So same thing, point, slope. I'm going to use point, slope, form. Shocking news there. So I'm going to plug those 3 values in. Y minus the y coordinate, this loop, x minus the x. And again, minus a negative, let's go plus. So I'm going to go ahead and distribute, take a look at it, probably add that 4 over. So 4 times x, 4 times 5. And then let's just add 4 over. So 24. I'm glad we don't have to draw that with the 24. That seems kind of big. Quick question before I do the points. Do you remember the name of this form of a line? Slope intercept. We'll get to that. All right, my 3 points. Kind of setting them up here. Now this time you do have x in your equation. So whatever number I select for x, then I'll calculate its corresponding y. You can pick any numbers for x. My only advice is, 24 is a little big. I'd probably pick small numbers for x just to make it easy on yourself. So I'm going to start with 0. 4 times 0, 0. Plus 24. Got it. Pick another nice small number for x. Let's go 1. 4 times 1, 4. Plus 24. Let's do a negative just for funzo. I'm going to do -1. 4 times -1, -4, plus 24. Got it. And again, you might use 3 different numbers for x. Totally fine. They'll just have different answers. Infinite amount of points on the line. Any questions on that one?
Sorry, how did you get the 24, 28, and 28?
So if you put 0 in for x, 4 times 0, plus 24, 4 times 1, you put that. Anything else I can answer for you there? Okay. All right, here comes some more of my excellent drawing skills. Find an equational line that passes through the point, has an indicated slope, sketch the line by hand. Okay, so I see they give me point and slope. So I'm like, oh man, where are this, point, slope? Okay, yeah, I can do it that way, then we can draw it. You could also, because I'm going to show you both ways, you could also get the equation of the line once you've drawn it. I think it might actually be a little easier. So I'm going to go back to our first example. I can plot that point and I can count out a slope of -3. I mean, how hard is that? So I'm going to plot -3, 6. And then of course I'm going to count out my slope of -3 over 1. And I'm going to put several points on because I want to try to draw it as straight as my drawing skills will let me. So I'm going to go down 3, right 1. Down 3, right 1. Got it. Down 3, right 1. Why not? One more. Okay, let's draw it. Now, with hardly any work, I can get to that equational line right now. Because if I want to use my y equals mx plus b, okay, I got everything. Slope they gave me. Hopefully, like I said, I did a lot of points on the line because I wanted it to be pretty straight and accurate. Because I'm like, oh yeah, it hits the old y-axis right there. There's your b, -3. Done. Now, you could have, just to show you, and I don't care, I'm not one of those teachers that's like, you have to do it this way. As long as you can get the answers, there's multiple ways to do these. I could have just, before I even drew it, done it like this guy. I could have done my y minus the y coordinate, the slope, x minus the x coordinate. If you go through and distribute and all that, you'll get the same answer, okay? I don't care how you do it, as long as you come up with the correct final answer. All right, this one's fun. Let's do this guy. So undefined slope. Weird, okay? So I'm pretty sure I'm not gonna try to start that. I mean, how am I gonna write undefined in front of the parentheses and distribute undefined? That just seems weird. So I'm gonna try to draw the line first and get it from that. So I'm gonna plot negative 10, 4. I know the graph grids are 10 by 10, so I'm just going to the edge here and up 4. Now we talked about undefined slope earlier. A line with undefined slope, vertical. Draw yourself a vertical line through there. Try to draw it straight if you can. Okay. Now, vertical and horizontal lines are the easiest equations to write. All vertical lines, up and down, will always hit your x-axis. So they're always x equals. And then, just look at your line or look at the point. Where does our line hit the x-axis? At what number? Yeah, negative 10. Yeah. So vertical, horizontal, easy. Don't draw this, just look at this, because you might see this on the homework. What if I gave you this line? With no work, what's the equation of that blue dashed line? Y equals 2. Horizontal lines always hit the y-axis, hits it at 2. Just a little review. I know you know it, but you might be a little rusty on your equations and lines. All right, last thing we've got. Of course, got to do a word problem today. Why wouldn't we? So a jeweler's salary was $28,500 in 2000 and $32,900 in 2002. Glad we have such updated data. That's awesome. Jeweler's salary follows a linear growth pattern. What will the salary be in the year 2006? Okay, so first I would try to, you can translate this data into coordinates, into ordered pairs. Now it doesn't matter if you do like salary, year, year, salary. Just keep it consistent, keep them lined up. But just generally in math, if you have some sort of number in your problem, value, and it's a time measurement, years, date, months, etc., they usually will put those as the x coordinates. So that's how I'm going to do it. So in the year 2000, we made 28,500. And I just left the comma out of the 28,500 because I didn't want like crazy looking commas happening up here, okay? And then of course in 2002, I made 32,900. Okay. So I'm like, all right, well, I've got 2 points. We're in a lesson about linear growth pattern, lines, 2 points, lines, I don't know. Let's find the slope between it and see what happens. Probably need your calculator for this. So I'm going to do my y2, second y coordinate, minus the first. x2, probably could do this part in your head, x2 minus x1. So take a minute, punch that in your calculator. Maybe you can do that in your head. Yeah, I got it in my head. You can do the bottom in your head for sure. You can do the top in your head too, right? Mental math, we rock at mental math. All right, what's your slope? Olivia, what do you got?
4,400 over 2.
Like it. And then I'm just going to divide that out. Now, why is this significant to our problem? Okay, why is the slope relevant to the jeweler's salary? Well, slope, remember, is also what we call the rate of change. You're comparing the salary to the years. So really this is over now 1. So every 1 year, he's getting a $2,200 raise. So every single year, you're making an extra $2,200. So I can make this super easy now for us. Now, if you were doing this the book way, I'd be using point slope form to write an equation, and I distribute, and I plug in 2006, and it'd take me like 3 more minutes. But we don't have to do all of that. Patterns, math's all about patterns. So now they want you to get the salary in 2006. So we can just use a little pattern, aka common sense math. So from 2002 to 2006, easy question. How many years is that? 4, right? 4 years. Now, you are getting $2,200 raise each year. So how much more money are you going to get in 4 years? 8,800 multiplied by 4. We're going to get an additional 8,800. 4 times 2,200. Now, I can easily get you the salary. So we left off at $32,900 was his last salary. He's getting $8,800 more over the 4 years. Add it together. What's $32,900 plus 8,800? Got it. I'm going to throw a dollar symbol and circle it. Got it. And do I need all, like how I wrote out all that little like piddly computation? No, we can do a lot of that in your calculators. All right, questions on that? Last question I have for you before I give you your homework. I don't know why, I've been getting asked a lot about the first one in the homework today. So if you have a vertical line, what type of line would be perpendicular to it? Good work, good work. You got it. So, now the other thing too,